Dear students, welcome to problem solving session number 3 in the level 1 of the problem solving sessions. The chapter is chemical bonding in physical chemistry. So in 2 of the problem solving sessions, whatever we have done, we have discussed about how we can solve the problems related to chemical bonding. We have solved problems regarding to various type of problems regarding the VSEPR, regarding the MO, and also the Lewis dot structure of different molecules. So now we move on to our problems today, and they are as follows. The first question is, which out of NH3 and NF3 has higher dipole moment and why? For information, we can say that NH3 or ammonia, this has a dipole moment equal to 4.9 into 10 to the power of minus 30 coulomb meter, and NF3 has a dipole moment is equal to 0.8 into 10 to the power of minus 30 coulomb meter. So that's a huge amount of difference between the dipole moments of NF3 and NH3. Obviously, the dipole moment of NH3 is greater than the dipole moment of NF3. Now we have to account for the reason and why it is. This is mainly because in case of ammonia, the orbital dipole due to the lone pair and the resultant dipole moment of the NH bonds act in the same direction. But in the case of NF3, the orbital dipole acts in the direction which is opposite to the resultant dipole moment of the 3 NF bonds. Now as a result, the net dipole of the NF3 or the nitrogen trifluoride becomes much less than that of the ammonia molecule. This can be illustrated well if I draw you the figure of both of the resultant dipoles of NH3 and also that of the NF3. So here you have nitrogen, here you have the hydrogen, here you have the hydrogen again, and here you have the hydrogen. Here the lone pair is housed. So this is mu2 mu1. So all the resultant dipoles of the individual bonds act in the same direction, and we can see that the total moment is equal to mu1 plus mu2. This is in the case of ammonia. Now in the case of NF3, the thing is a little different. So here you have the nitrogen, here you have the fluorine, and the other fluorine is here, and here lies the lone pair. So there is mu1. But the individual dipoles that are present, they are acting in opposite directions, that is mu2. Therefore we can say that mu is equal to mu2 minus mu1. So this is the reason why the resultant dipole moment of ammonia is greater than the resultant dipole moment of NF3. So I have illustrated you with the help of the diagram.